Nice to meet you. I'm Khatar Choktai and you're watching my YouTube channel, School of Advanced Chemistry. Let's talk about alkanes. Organic part first for O-level chemistry students. Let's talk about it. Alkanes are the hydrocarbon, saturated hydrocarbons. Those are having all carbon-carbon single bonds in it. If any hydrocarbon that is having all carbon-carbon single bond in it, it is said to be an alkane or it is said to be a saturated hydrocarbon. So alkane is the second name of saturated hydrocarbon. What are the hydrocarbons? Hydrocarbons are the compound containing carbon and hydrogen only. Carbon and hydrogen only. Any compound that is having only two elements, carbon and hydrogen, these compounds are said to be hydrocarbons. A general formula of alkane homologous series is CnH2n plus 2. CnH2n plus 2. Here n is equal to number of carbon atom. If I am going to put n is equal to 1, then the formula will be CH4. It's methane. If I am going to put 2 over here, if n is equal to 2, then the formula will be C2H6. That is known as ethane. If I am going to put 3 over here, if n is equal to 3, then the formula will be C3H8. This is called propane. If I'm going to put 4 over here, if n is equal to 4, then this formula is said to be C4H10. That is called normally known as butane. So this is the general formula, CnH2n plus 2. And this formula is followed by all normal alkanes, all type of normal saturated hydrocarbon, open chain alkane or open chain carbon. And formula is CnH2n plus 2. That is said to be the general formula. Now come towards the properties of alkane. First of all, alkanes are generally said to be or supposed to be unreactive molecules. Alkanes are unreactive molecules. They give only two reactions. Number one, they can be burned, they can give combustion reaction, and they can give substitution reaction with halogens. Alkanes are supposed to give only two type of reaction. Number one, they can react with oxygen at high temperature. That is said to be combustion. They can give combustion reaction. They react with oxygen at high temperature and it is called combustion. And the second reaction is said to be substitution reaction. Alkanes react with halogens, Cl2, Br2, etc. In case of sunlight or UV light, or in case of heat in dark, alkanes can react with halogens, and this reaction is said to be substitution reaction, or specifically it is known as free radical substitution reaction. So there are only two chemical properties of alkanes over here. Number one, they can react with oxygen. They can change themselves into carbon dioxide and water. That's called combustion reaction. They can combust themselves. And number two, they can react with halogens. They react with halogens, they react with oxygen, and there are only two chemical properties for the alkanes. Second thing is alkanes are simple covalent molecules. So they are having low melting and low boiling point. Basically, generally speaking, alkanes are having low melting, low boiling point, low viscosity, and so on, etc. First four members of the alkanes homologous series, methane, ethane, propane, butane, are gases at room temperature. As I told you, alkanes are simple covalent molecules. They are having low melting, low boiling point, and they are having a weak van der Waals forces between them. So the first four members, methane, ethane, propane, and normally known as butane, they are gases at room temperature. All the members in this homologous series show similar chemical properties. In the family of alkane, that is starting from methane, ethane, propane, butane, pentane, hexane, heptane, and so on. All members in this homologous series show similar chemical properties, but they are going to change, they are going to show different physical properties. As the number of carbon atom increases down the series, then there is change in the physical properties, but chemical properties remain same. So all alkanes show same chemical property. All alkane can react with oxygen. All alkane can react with bromine, with Cl2, but the physical properties are not pretty similar as we descend down the series of alkane. I'm going to talk about the physical properties, then size of the molecule is going to increase as we trickle down. Mass of the molecule is going to increase. Melting point, boiling point increases down the series. Viscosity, they are becoming more viscous as we move down the series. As the alkane is having more number of carbon atom, it will be more viscous. But flammability. Flammability decreases. As we move down the series, physical properties changes. Yes, it is true. Melting point increases. Boiling point obviously increases. Viscosity increases. But flammability, ability to catch flame, is called flammability. So flammability decreases down the group, down the series, down that family, down that homologous series of alkanes. Alkanes are insoluble in water and they are less denser than water. These are not soluble in water because basically they are non-polar covalent molecules. They are non-polar. So non-polar covalent molecules are insoluble in water. Alkanes are non-polar compound. They are not soluble in water. They do not react with water. They do not react with metals. They do not react with alkalis, with acid, etc. So alkanes are non-polar compound. They give no any other chemical or physical reaction with water, with metals, with acids, with alkalis, and so on. Now come towards the combustion reaction. Let's see over here, if I'm supposed to combust ethane, it will react with oxygen to make carbon dioxide and water. The combustion reaction is the reaction of a compound with oxygen at high temperature. So as far as the hydrocarbons reaction is concerned, they change into two compounds on complete combustion. In complete combustion, there is the formation of carbon dioxide gas and water compound is formed, or water molecules are formed. Basically, the carbons, number of carbon atom, all carbon atom changes themselves into CO2 and all hydrogens change themselves into water. So let's suppose in this case, C2H6 plus oxygen goes to CO2 and H2O. Here are 2 carbon atoms, so 2 mole of CO2 will be formed. Here are 6 hydrogen atoms, then half of the mole of hydrogen atom, that is equal to 3 in this case, 3 mole of H2O will be formed. This is called complete combustion. Once again, I'm going to repeat my sentence that on complete combustion, there are only 2 products as far as the alkanes combustion is concerned, and there is a formation of carbon dioxide and water. Carbon dioxide is made because of the carbon, and H2O, that is the oxide of hydrogen, water, is made because of due to the presence of hydrogen element in the compound. Here is a general formula that you can write about the combustion. CXHY plus XY by 4O2 goes to X mole of CO2 and plus Y by 2 H2O. This is said to be a general combustion of all hydrocarbon. For alkanes, for alkenes, for alkynes, all type of hydrocarbon can be fit into this equation, into this formula. Here X is the atoms of a mole of, basically mole of carbon atoms, and Y is the mole of hydrogen atom. So you will put the values of X and Y and you can get the balanced equation. Next thing is, if you are specifically going to balance the combustion of equation of alkene, here it is. Basically, alkane, CnH2n plus 2 is a general formula of alkane, plus how many mole of oxygen will be required? 3n plus 1 divided by 2. If you are going to combust any alkane, then what will be the need of oxygen for this alkane? It will be equal to 3n plus 1 divided by 2. This is the combination of moles of oxygen needed for the alkane for the complete combustion. If you are supposed to do complete combustion, then once again there is the formation of CO2 and H2O, and at that time the mole of oxygen will be equal to 3n plus 1 by 2. That is the mole of oxygen needed for the complete combustion, and in this way, in this equation, you can write the equation for the complete combustion of any alkane. If the compound is not having just carbon and hydrogen, then the compound is said to be derivative of hydrocarbon. I mean, any compound, if it is having carbon and hydrogen plus nitrogen or sulfur or Cl and so on, then this compound is said to be derivative of hydrocarbon. Yes, you can combust the derivative of hydrocarbon as well on combustion of any compound. For example, if I'm going to combust a thioether, that is a derivative of hydrocarbon, for example, it is having carbon, hydrogen, sulfur. When it is combust, for the sake of complete combustion, it is supposed to be combust completely. Then there is the formation of three type of oxide. Why three type of oxide should be there, or that is going to be formed over here? The reason is, here are basically three elements: carbon, hydrogen, and sulfur. Three elements are over here. Each and every element is going to react with oxygen at high temperature and going to make a stable oxide. Carbon dioxide, carbon will change into carbon dioxide, hydrogen will change into H2O, hydrogen oxide, sulfur will change into sulfur dioxide. So this is the complete equation for the reaction of this thioether. That is not a hydrocarbon, that is not an alkane, that is the derivative of hydrocarbon, but you can write the combustion equation for any compound if it is either it is a hydrocarbon or not, or it's a derivative of hydrocarbon. So you can write the complete combustion just making the oxide of different element present in that formula, in this formula. Next thing is that is said to be photochemical reaction, and it is also said to be substitution reaction. Photochemical reaction are triggered by photons, by the light. So that's why they are said to be photochemical reactions. Here I'm going to talk about the specific reaction. Those are said to be substitution reaction. I mean, reaction of alkane with halogens. Reaction of alkane with the halogens is said to be are known as substitution reaction. Substitution reaction of alkene with chlorine is also known as a photochemical reaction. The type of reaction is said to be are also known as a photochemical reaction, and this reaction is basically carried out in the presence of, as I told you, in the presence of ultraviolet light, in the presence of sunlight, or in the presence of heat. So basically sunlight, what is the function of sunlight? What is the function of heat? It is going to give the energy of activation, especially to the halogens. In this reaction, first of all, halogen is broken down. Cl-Cl bond is broken down, Br-Br bond is broken down, and then there is the substitution mechanism. Hydrogens are replaced by halogens. For example, methane reacts with chlorine in the presence of ultraviolet light. So here is the mixture of product that can be made. Number one, if I'm removing one hydrogen of methane and substituting one Cl over here, then it will be chloromethane, one chloromethane or simple chloromethane or monochloromethane. If I am going to substitute the second hydrogen of the methane, then it will be known as or said to be dichloromethane, mean two halogens have been substituted. So it is said to be dichloromethane. If the third hydrogen is replaced or substituted, and same is the case for the fourth one, then there will be the formation of trichloromethane, and finally we are going to have tetrachloromethane. If we are supposed to react with excess Cl2, when methane or any alkane, if it is supposed to react with excess halogen, excess Cl2, then all of its hydrogen will be substituted by that halogen. So if you are using limited halogen, then you will substitute only one hydrogen. If you are using excess halogen, you will substitute all halogen that is present in the formula, and hydrogens are substituted or replaced by the halogen atom. And every time, whenever you are going to replace hydrogen by Cl, these hydrogen will change themselves into HCl, hydrogen chloride. Replaced hydrogen, substituted hydrogen will change themselves, will make a new compound that is said to be HCl, HBr, hydrogen halide will be formed. Once again, I'm going to explain the example of methane with Cl2. If you are going to react with methane and Cl2, then HCl and halo compound will be formed. So if you are using halogens in excess quantity, then all hydrogen will be replaced. Now come towards uses. Basically, alkanes are used, main use of the alkane is they are used as fuel, as they can combust themselves. I mean, they are highly combustible. It produces carbon dioxide, water, and moreover, the main thing is energy that is being formed on combustion. So they can be used as a fuel. They are very much good fuel. The next thing, they can be used to make other compound. For example, carbon sulfide, carbon black, and they are used to make hydrogen. I mean, they can be cracked into different further compound as well. So these are the basic main uses of alkane. That's all about today, all about alkanes. As far as O-level chemistry syllabus is concerned, please subscribe my channel, hit the bell icon, and share it with your friends. Thank you very much. Have a nice day.